Hello, everybody. We are going to start off class today with a warm-up, as always. This one's going to be on right triangle trig, because that's going to lead into us continuing learning target 2 today. So just a reminder before we start, in case you forgot, right triangle trig, also known sometimes as SOHCAHTOA, is sine, cosine, and tangent, where sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Right triangle trig allows us to solve for side lengths of right triangles. So I'd like you to pause this now and try and solve for x. Okay, now that you've tried this on your own, we're going to go through it real quick. So the first thing you do is you look at the angle you're going to use, right? The input of trig functions is always an angle. So we have to pick the angle we're going to use. Now, technically, I could solve for this other angle, right? I could solve for angle A because I know that there is always 180 degrees in a right triangle. But I don't need to. I already have an angle. So now with respect to this angle, I need to label my sides. Okay, well, x, that's the hypotenuse because the side across from the right angle is always the hypotenuse. The side across from the angle is going to be the opposite side, and then the side, touching the angle that isn't the hypotenuse, that's going to be the adjacent side. So we can see that we have adjacent and we're solving for hypotenuse. So we need to choose the trig function that has adjacent and hypotenuse in it, and that is cosine. So that's what we're going to use here. We will take cosine of 37 degrees equals adjacent over hypotenuse, which is x, and we need to solve for that. So to solve for that, you'll multiply both sides by x because we need to get it out of the denominator. That's going to be x times cosine of 37 degrees equals 11. Divide both sides by cosine of 37 to isolate x. You want to keep it exact until the very end because cosine of 37 is going to be a decimal. You don't want to round in the middle of a problem. So we'll keep it exact until the very end, and then we will just type this into our calculator. 11 divided by, make sure your calculator's in degrees, cosine of 37, close parentheses, that is 13.77349, blah, blah, blah. So we will say round to the nearest hundredth is usually a good idea. That x is 13.77. Okay, so that's how we use right triangle trig. Right triangle trig allows us to solve for side lengths, right? For trig functions, the input is the angle, the output is the side length. It's the side ratio. So you can solve for side lengths with right triangle trig. With inverse right triangle trig, it's flipped, right? We know from unit 1 that inverses, input and output is flipped. So inverse trig functions, we input the side lengths, the side ratio, and our output is the angle. So we use inverse trig to solve for angles. So let's see an inverse trig one as well. First thing we're going to do is identify the angle we're working with. Obviously, if we're solving for question mark, that needs to be the angle we're labeling our sides with. So this will be my angle. Then hypotenuse is always my hypotenuse. 9 is going to be my opposite, and 21 will be my adjacent. So now I'm looking for the trig function that has adjacent and opposite in it, right? I don't have my hypotenuse, so I can't use an unknown to solve for another unknown, right? So I look for the trig function that has opposite and adjacent, and that is tangent inverse. So this will just go right into my calculator. Tangent inverse of opposite over adjacent equals question mark. Okay, so I'll just type that in. tangent inverse, which is second tan on the school calculator. 9 divided by 21, close parentheses, that's going to give us 23.19859, blah, blah, blah. We will say that that angle is 23.20 degrees. Okay, so that's just a quick refresher on right triangle trig. You won't specifically be solving right triangle trig questions, but as we use trig values here, it's important to know that sine is opposite over hypotenuse and cosine is adjacent over hypotenuse and tangent is opposite over adjacent. That's the stuff that's going to help us here. But to continue our work on learning target 2, I'm going to introduce you to what the unit circle exactly is, and then we're going to use special right triangles that we did in class on Wednesday and right triangle trig to find these trig values on the unit circle. So the unit circle is a circle centered at the origin with a radius of 1. That's why it's called unit circle, because it's 1 unit. Okay, an equation for a circle is x minus h squared plus y minus k squared equals r squared, where hk is the center. So for this one, because it's centered at 0, 0 and has a radius of 1, it's just x squared plus y squared equals 1. Okay, you can see it there. We have used trig to triangles with no reference in the coordinate system, right? The triangles we saw yesterday, the triangles we just did in the warm-up, that's what they were. They were just triangles. But we can actually plot these triangles on a coordinate system and use the fact that the radius is the hypotenuse to find some interesting trig values. Okay, so what we're going to do is we are going to put these special triangles, the 30, 60, 90, the 45, 45, 90, into the unit circle to find these special trig values. You can find trig values for any angle, but these ones are common, and because they're the special right triangles, they have easy trig values, helpful trig values. So I wanted to remind you of these special right triangles, right? You should already have this in your notes from yesterday, right? These are just the proportions that all 45, 45, 90 and 30, 60, 90 triangles have with their side lengths. Okay, but what we want to keep in mind is that we are putting these on the unit circle, right? When I say that these triangles will have a radius 1, I mean here is the hypotenuse of the triangle. So the radius is the hypotenuse, it's 1. So when we place these special right triangles onto the unit circle, the radius is going to be 1. So we need, for this triangle, we need x square root of 2 to equal 1. And for this one, 30, 60, 90, we need 2x to equal 1. So over here, that's going to mean that if x radical 2 equals 1, then x must equal 1 over radical 2. So my legs, which are x, will be 1 over radical 2. And then here, if x equals, or 2x, my bad, equals 1, then that means that x is going to equal 1/2, right? Because you'll divide both sides by 2. So that would make the shorter side 1/2, and then the longer leg, radical 3 over 2. These values, radical 3 over 2, 1/2, 1 over radical 2, are all over the unit circle. Okay, another thing to note, and we talked about this when we did radicals, is that there is such thing as rationalizing a radical where we don't have a radical in the denominator. So it's important that you guys know, if we multiply by radical 2 over radical 2, which is a fancy version of 1, we get radical 2 over 2. Okay, you're going to see radical 2 over 2 a lot. So just know that these are equivalent, and it'll make your life a lot easier when it comes to the unit circle. So these are kind of the triangles I also want you to add to your notes, because these are the ones in this class we're specifically going to be using. When I was talking to you guys about the 45, 45, 90 and the 30, 60, 90, I said it'll be helpful for the unit circle and it will be helpful for the ACT. Everything we did in class Wednesday, helpful for this and the ACT. But these triangles right here with hypotenuse 1 is really what we're going to be dealing with in this learning target. Okay, on the ACT, you'll see all types of variations. For this learning target, we're only going to see the hypotenuse as 1 because these are all going to be on the unit circle. Okay, so pause here, put these two triangles in your notes, and then we're going to form a unit circle using these triangles. So this is the start of the unit circle. What we really need to remember is that our radius is 1 and this circle is centered at the origin on a coordinate plane. So if we're centered right here and our radius is 1, that means that all of these distances that are along the axes are also 1. So we can get ordered pairs out of this. When I go over 1 and up 0, that's the xy pair, 1, 0. When I go over 0, up 1, that's the xy pair, 0, 1. So at 90 degrees, our ordered pair is 0, 1. At pi over 2, our ordered pair is 0, 1. Then if I go over to the left 1 and up 0, that's going to be the ordered pair, the xy pair, negative 1, 0. So at pi and 180, my ordered pair is negative 1, 0. And then lastly, if I go straight down, so I go over 0, down 1, that's going to be the ordered pair, 0, negative 1. So those are the easiest to find, right? Because we've plotted those points on a coordinate plane before. So what we're going to do to get these other trickier points is use our 30, 60, 90, 45, 45, 90 triangle. So if I take this line right here, that's my radius, so my hypotenuse is 1. If I drop a perpendicular down, well, my angle is 60 degrees, so right here is going to be 60 degrees. Well, all of a sudden, that's a 30, 60, 90, right? That is this triangle right here, where my short side is 1/2 and my long leg is radical 3 over 2. So I know that this distance is going to be 1/2 and this distance is going to be radical 3 over 2. So we know our ordered pairs, we have our x value and our y value. It's our horizontal distance and our vertical distance. Well, we can see we go over 1/2 and up radical 3 over 2, and that's how we get the ordered pair 1/2 radical 3 over 2. We could also take this triangle and put it in a different quadrant. So now, for example, I took this triangle and I rotated it into the third quadrant. Okay, the things are upside down, so let's get rid of those now. But it's still got a reference angle of 60 degrees and a hypotenuse of 1. So still, this is 1/2, but now because it's in a coordinate plane, remember, and we're going to the left, that's going to be negative 1/2. And again, because we're in a coordinate plane, we're going down, this will be negative radical 3 over 2. That's going to make this ordered pair, my x, comma, my y, negative 1/2, comma, negative radical 3 over 2. So we're basically just going to take these special right triangles, place them all over this circle to get a bunch of ordered pairs, and that's what our unit circle is. Okay, so if we look here, here's the 45, 45, 90, and I went ahead and just pasted it in here. We're missing the little 2 right here, right? Remember that 1 over radical 2 is the same thing as radical 2 over 2. Those are interchangeable, and they're used interchangeably through worksheets, videos, anything you see with the unit circle. So let's take that and let's use this quadrant now. Let's draw a 45, 45, 90. So here goes my radius. I drop a perpendicular. I've got my triangle, right? It's a right triangle. This angle, which is my reference angle, which is again why we learned what reference angles are. We use them in this learning target. I've got my reference angle is 45 degrees. Well, I know my hypotenuse is 1. My legs are both radical 2 over 2. But now what we have to notice is, unlike on this side, this point, where they're both positive because they're in the first quadrant and x and y are both positive in the first quadrant, we're in the second quadrant where x is negative. We're going to the left. So this ordered pair right here would be negative radical 2 over 2, comma, radical 2 over 2, because we're still going up. So we do what we just did a bunch more times, and we get the completely filled in unit circle. This is what you will need to memorize and what you will be assessed on. Now, normally it would be I hand you a blank one of these in person and you have like 10 minutes to fill it all in. But obviously we can't do that virtually, so you're going to do it online, and I will talk a little bit more about that in a moment. But first, let's again run through and see how this was filled in. So a lot of this stuff you've already seen before. It is not new, right? The fact that 90 is here and it's the same thing as pi over 2, you know that, right? All of the angle measurements we've already been through. The one thing I would add to this photo is just the reminder that this is 360 degrees and also 2 pi. Those are equivalent, and you need to know those. Okay, really what's new to us here is the ordered pairs, and the ordered pairs are what is going to allow us to find the trig values, so they're definitely needed. So we can see I've added my special right triangles, and you can see that they go right in, and that is how we get our coordinate points, right? You go over 1/2 and then up radical 3 over 2. That's going to be the ordered pair, radical 3 over 2, comma 1/2. Right? But let's see if we put it in a different quadrant. So we need our reference angle to still be 45. So we'll put it here instead. And you'll notice the main thing that'll change is both of these need to be negative. So that's how we get a negative radical 2 over 2, comma, negative radical 2 over 2. Right? Then what we can also do is think about it, this is for memorization purposes, it's really just the same coordinates over and over again, but we keep in mind that in this quadrant, both x and y are positive. In this quadrant, x is negative, but y is positive. In this quadrant, they are both negative, and then in this quadrant, we've got a positive x and a negative y. So really, if you can just memorize the first quadrant, then you've got all of them memorized. Okay, this is a video that's embedded in the slides presentation that has some memorization tricks to it if you want to watch that. I am not making you guys memorize this or assessing you on this just for fun. The unit circle is something that you will use in pre-calc and calculus, and calculus is a non-calculator course, so you won't be able to type these things into your calculator and get them. You're going to have them memorized. It's also a speed thing, right? When you're in pre-calc and you're in calc, you don't want to be spending time on right triangle trig. You want to be focusing on the harder material. Okay, so this is something to memorize. I actually had, and I quote, a kid that is in person this semester that's in calculus right now come to my room and say, you know, Miss Demarest, I really should have listened to you when you said memorize the unit circle. So this is not one of those things that you want to fleetingly memorize for the sake of this course and then forget. It's like factoring. It's going to keep showing up again and again and again. You'd be much better off if you just really took it seriously the first time. So even though we're virtual, the way I'm going to assess you is through a game. I'll open it here in a second. It is just a fill in the blank game. You're basically filling in a blank unit circle, but here's how it sees if you have it memorized. You need to do this in under 5 minutes. You'll earn no credit for any attempts over 5 minutes. I don't care if you get in 100 in 5 minutes and 2 seconds. Right? It's got to be under 5 minutes. You will get a percentage at the end of the game. That percentage will go into the grade book out of 10, and that's your quiz grade. This is quiz 9. That's how it's going to be graded. So if you get a 90%, you'll get a 9 out of 10. If you get an 83, you'll get an 8.3 out of 10. If you get an 100, you'll get a 10 out of 10. Okay, when you submit it, this is what it's going to look like, right? Here's your score. That would be a 9.6 out of 10. You need to include a timestamp with the date and time you took it, as well as your time and your score. Okay, all those things need to show. Every semester, somebody turns in the same screenshot as somebody else, and it's a pain. I have to contact their parents. They both get zeros. Just the game, I promise, is not that hard. You practice it a couple times. You get better at it as you practiced it. And then bam, you've got it. A majority of the class, at least the part of the class that does it, gets mastery on this. Okay? This is going to be due next Friday, which is 5/21 at 11:59 p.m. If it is late, the highest grade you can earn is a 9 out of 10. So you can turn this in late. You can remediate it till the 24th, but then the highest you can earn is a 9 out of 10. So I would really recommend doing this and getting this in on time. Okay? Okay, so I just wanted to quickly show you guys what the game looks like. So we hit play, our timer starts, and then we just need to place where these things are. So 240 degrees, I know that's in the third quadrant. There we go. Then -1, I go over 1 up 0. That's that ordered pair. 210, that's here. 5 pi over 4, that's here. Right? If I get one wrong, it goes like that. Okay, radical 2, oh, it's going to be over here, right? So it's yellow, I lose a little points. Okay, and then obviously if I quit early, I'm not going to get a score. But you just do that till you finish, till you go through them all. And then you just practice until you get it in under 5 minutes. So now that we've determined what's on the unit circle, let's see how we actually use it. Okay, we are going to figure out sine, cosine, tangent values of unit circle angles using the coordinates on the unit circle. So let's start with just sine of 60 degrees. This is the one we'll focus on because that one's the easiest to see right off the bat. So we'll do this one in green. If I take a look at this, I know that this is my triangle right here. Okay. That's the triangle I'm looking at. And then I also know that that means that this is my ordered pair I'm working with. Right? That comes from the 30, 60, 90 triangle. Well, let's just pretend we don't have the ordered pair yet. Let's take a look at if I wanted the sine of 60 degrees, just like we did in the warm-up today. Here's my angle. Here's my opposite side. Here's my adjacent side. Here's my hypotenuse. Well, we know that sine of theta is opposite over hypotenuse. So sine of 60 degrees, this triangle here, is going to be opposite, which is radical 3 over 2, over hypotenuse, which is 1. So it's just going to be radical 3 over 2. Now, because our radius on the unit circle is always going to be 1, and dividing by 1 doesn't do anything, when we're talking unit circle, sine of theta is just always going to equal opposite. For that same reason, in the same way, cosine of theta is always going to equal adjacent. So that is where this comes in. That is where this fact comes in. Because sine is always your opposite, which is basically just your y value, right? Your opposite is your vertical distance, so that's going to always be your y coordinate. Your adjacent is your horizontal distance, so that's going to be your x coordinate. X comma y is always cosine comma sine. So this is something I want you to put in your notes. This is how you're going to use the unit circle. Everything we do in this learning target is going to rely on the fact that the ordered pairs around the unit circle come from the XY pair. So what that also means is if I wanted to do the cosine of 60 degrees, that's going to be the x coordinate at 60 degrees. That's 1/2. So I know by just looking at my unit circle that cosine of 60 degrees is 1/2. So now let's look at cosine of 300 degrees. So when I'm figuring these out, I'm always graphing in standard position. So this would be 90, 180, 270, and then I'd go 30 more. So here's my terminal side. Now, my reference angle here, right, this is why we did reference angles in Learning Target 1. My reference angle here would be 60 degrees, right? Because if this is 300 and this is 360, and then that distance right there is 60 degrees, which means we can make a 30, 60, 90 triangle here. We know this side length is 1/2. This side length, it's covered up by this box, is negative radical 3/2. So my ordered pair, I go over 1/2, down negative radical 3/2, is going to be 1/2 comma negative radical 3/2. Well, my cosine is my x coordinate. So cosine of 300 is just going to be the x coordinate at 300. And so that's going to be 1/2. So that's really what we're going to be doing. We're going to locate the angle on the unit circle and then use the ordered pair being cosine comma sine to find these trig values. So right now, you're probably understandably a little bit confused, but we're going to keep doing examples and hopefully that'll help clear it up. We're also going to spend a good chunk of time Monday and Tuesday on this learning target as well. So we know that sine and cosine are on the unit circle, right? Those xy pairs around the unit circle are the cosine sine values for those specific angles. But what about tangent? Tangent of 60 degrees. So let's go back to that first triangle we were working with. So looking at this 30, 60, 90 triangle here, if we wanted to find the tangent of 60 degrees, we would take this as our starting angle. Radical 3/2 would be our opposite side. 1/2 would be our adjacent side. 1 would be our hypotenuse. Remember, tangent of theta is opposite over hypotenuse, or opposite over adjacent. So in this situation, remember what we just saw was that because the hypotenuse is 1, sine of theta is opposite over hypotenuse. But again, the hypotenuse is 1, so dividing by 1 doesn't do anything. That goes away. Cosine of theta is adjacent over hypotenuse, but again, hypotenuse is always going to be 1 on the unit circle. It's the whole point. So that's going to go away. So sine of theta is opposite. Cosine of theta is adjacent. So notice that tangent is going to be opposite, which is sine of theta, over adjacent, which is cosine of theta. So this is something I want you guys to add to your notes, that tangent of theta is equal to sine of theta over cosine of theta. We're not going to take the time to draw the triangle each time, find the reference angle, label the sides, and use right triangle trig. We're going to use the coordinates already given to us on the unit circle to find all of our trig values. So because we're only given sine and cosine, we need to think of tangent in terms of sine and cosine. So tangent of theta is sine over cosine. So then what I can do is I can go back to this slide here and we can say, okay, tangent of 60 degrees is really going to be sine of 60 over cosine of 60. And we saw a couple moments ago that sine of 60, that's going to be our y coordinate, is radical 3/2. Cosine of 60 is our x coordinate. That's going to be 1/2. And now we just simplify this fraction, right? We have a fraction over a fraction, which we know is not allowed, but we also know that we can keep change flip. So that's going to be radical 3/2 times 2/1. 2's will cancel, so the tangent of 60 degrees is radical 3. Everything we do in this learning target is going to be exact. Sure, you could type tangent of 60 degrees into your calculator, but you'll get 1.7 blah, 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 blah. That's radical 3 is a decimal. We want to keep it exact, leave everything in radical form, so that's another reason we have to use these special triangles. So in addition to sine, cosine, and tangent, there also exists their reciprocals. We have CSC, which is cosecant. That is the reciprocal of sine. So instead of opposite over hypotenuse, it's hypotenuse over opposite. We have SEC, which is pronounced secant. And then we have COT, which is the reciprocal of tangent, which is pronounced cotangent. Okay, now on here it says, I will give you these 3 on the test. Obviously, you guys will be making your own formula sheet so you can decide whether or not you give these to yourself. I would recommend you do, because might as well. But I just kept that on there because in years past, when tests are in person, this is something I provide on the formula sheet, whereas for sine, cosine, and tangent, I do not. Okay, so all this means for us is that if I'm asked for, let's go back to, let's pretend this is 60 degrees right here. We know that this ordered pair is, this ordered pair right here is 1/2 comma radical 3 over 2, right? So if I'm asking for, let's say, the cosecant of 60, what I'll do is I'll rewrite that as 1 over the sine of 60, and then the sine of 60 is something I can pull off of my unit circle, right? That's going to be my y-coordinate at 60 degrees. 1 over radical 3 over 2, keep, change, flip. Your cosecant of 60 degrees is 2 over radical 3. So in order to use the unit circle to find a trig value, 2 things need to be true. First is it has to be in terms of sine and cosine, right? We just saw tangent you can find on the unit circle, but to be able to find it, you have to put it as sine over cosine, right? Cosecant we just saw, we could pull that off the unit circle, but we had to put it in terms of sine. So the first thing you need to do is get the function in terms of sine and or cosine, so that we can actually pull it off the unit circle. The second thing is that our unit circle values only go from 0 to 360 and 0 and 2 pi. So if you are doing multiple rotations around or it's a negative angle, you need to figure out where the terminal side falls between 0 and 360 or between 0 and 2 pi to be able to find it on the unit circle. Let's do some examples and see if we can make some more sense of this. All right, let's take a look at this one. A little bit straightforward. We want cosine of 210. So the first thing I do is I find where that terminal side is, right? And what's nice about having the unit circle memorized is it's already there for you, right? If I were to take this and graph this, I'd put my initial side on the positive x-axis. Here, my terminal side would be right here. And then we'd put our rotation. But for this learning target, at this point, we are only focused on the terminal side, okay? Once we know where the terminal side is, we can figure everything else out. So I know that I'm looking at this ordered pair right here, negative radical 3 over 2, comma negative 1/2. But keep in mind the really, really important fact that our xy pairs around the unit circle are our cosine comma sine pairs. So since x is our cosine value, that means that at 210, our cosine is negative radical 3 over 2. So that gives me my answer. I know that cosine of 210 is going to be negative radical 3 over 2. And that one's done. Okay, let's look at tangent of pi over 3. So again, the first thing I do is I look and see where the terminal side would be. Well, here's pi over 3. So this is where I'm looking. Right? I know that tangent is sine over cosine, right? Just looking at this, I can't pull that off the unit circle. I can't pull tangent directly off of the unit circle because it's not on there. My ordered pair again is cosine comma sine. So the first thing I need to do is rewrite tangent so that's in terms of sine and cosine. So that'll be sine of pi over 3 divided by cosine of pi over 3. Now this is information I can pull directly off my unit circle, right? We know Our x value is the cosine, our y value is the sine. So that's going to be radical 3 over 2 over 1/2. We will keep change flip. Radical 3 over 2 times 2 over 1. Our 2's will cancel. And so the tangent of pi over 3 is radical 3. So that's what is meant by you need to make sure that the trig function is in terms of sine and cosine. We can't pull tangent off of our unit circle, but if we write tangent as sine over cosine, we can pull the sine and the cosine off our unit circle. Now, say I wanted to find the cotangent of pi over 3. There's actually two ways I can do this, keeping in mind that cotangent is the reciprocal of tangent. The first way I can rewrite cotangent then is 1 over the tangent of pi over 3. Right? So if I just go through the steps to find tangent of pi over 3, and I know that it's radical 3, I know my cotangent is 1 over radical 3. But again, that requires first finding tangent of pi over 3. The next way I can find cotangent, since it is the reciprocal of tangent, I know cotangent is going to be cosine over sine. So I could find the cosine of pi over 3, the sine of pi over 3, and then keep change flip, right? Cosine of pi over 3 is 1/2. Sine of pi over 3 is radical 3 over 2. 1/2 times 2 over radical 3. My 2's cancel, and I get 1 over radical 3. So either way is fine. The first way looks super simple here, but remember it required us finding tangent first. The second way, we just flip it at the beginning and then solve from there. Okay, the last example we are going to try together before you guys do your exit ticket is a negative angle. So this is in terms of sine, so I could find it on my unit circle, but the problem is negative 45 is not here. So there's two ways I can do this. The first way I can do it is use my skills from Learning Target 1 and just know that, I'm going to graph it in standard position. It's going to end up here, and then I can use this ordered pair to figure out the sine. Right, that's the first way you can do it, is you can just graph it in standard position, figure out where the terminal side is, and go from there. The second way you can do it is you can keep in mind that if I do a full rotation, no matter where I start that full rotation, I'm going to end up where I started, right? If I start here and do a full rotation, I'm going to end here. If I start here and do a full rotation around, I'm going to end here. So adding or subtracting 360 keeps you on the same terminal side. So we can first algebraically add 360 if we would like, right? We can either graph negative 45 on its own, figure out where the terminal side is, or if we want to find it on the unit circle, we can add 360, see that that is 315, then we know that both the angle negative 45 degrees, which as we saw would be graphed like this, and positive 315, which would be graphed like this, have the same terminal side. And if they have the same terminal side, that means we're working with the same ordered pair. So sine of negative 45 is going to equal sine of 315. So then sine is my y coordinate, so I know that that is negative radical 3 over 2. So before we go over your exit ticket, I wanted to remind you of what your homework is and what's upcoming in trig. So the first thing is the worksheet that was assigned on Wednesday, the 45, 45, 90, 30, 60, 90 triangle worksheet is due before next class. So if you're in first period, that's going to be Monday morning. If you are in second or fourth period, that is going to be Tuesday morning. Your exit ticket is due by 2:30 today if you would like to be marked present for attendance, though if you had to miss attendance, you can still earn credit for it if you turn it in late. Then your other homework is practicing memorizing the unit circle and playing that game. That is quiz 9. You can turn that in whenever you're done. Okay, again, quiz 6 is graded. Quiz 7 and 8 are in the process of being graded. As soon as you get those grades back, start corrections. The retakes will be next week. And then last but not least, final exam study materials will be posted this weekend. Okay, let's take a look at this exit ticket. So on this exit ticket, you need to tell me the cosine of negative 315 and the tangent of 2 pi. So I want you to pause this right now and try it on your own. And then in a moment, I will give you hints in case you need it before you want to submit your exit ticket. Okay, so here are some hints to help you with the exit ticket. The first one being a reminder that your XY pairs along the unit circle are your cosine comma sine pairs. Okay, specifically for cosine of negative 315, we know we can add 360 to that, and the terminal side would be here. And so the cosine of 45 degrees is the same as the cosine of negative 315. So we can take a look at this XY pair and pick out the X coordinate because the X coordinate is cosine. And then your hint for the tangent one is just a reminder that tangent of 2 pi over 3 is the same as sine of 2 pi over 3 and cosine of 2 pi over 3. So you can go to 2 pi over 3. You're looking at this ordered pair. It's going to be the sine, which is radical 3 over 2, over the cosine, which is negative 1/2. And you can simplify that fraction and you will get negative 1/2. Okay, so once you submit that ticket, you are done for your assignment for the asynchronous day, and you've got either the special right triangles homework or the quiz 9 to work on this weekend. Email me if you have any questions, but other than that, I hope you have a great weekend, and I will see you on Monday or Tuesday.